Hey everyone, Chang here. This is a skill building video series. Now for today's topic, we're going to focus explicitly on slope. I felt like in the last video I did sort of a piss poor job in explaining it, and so hopefully I can remedy that with this video. Now, slope. The common notation or the common variable for slope is m, okay? That's just, I don't know why they decided it, that's just the way it is. And this is what we normally associate with slope. Slope is the change in y. So this is a delta symbol, not a triangle. The change in y over the change in x. Now what does that mean? Well, slope is usually in relation to two different points. So we have one point right here and another point right here. Notice this, they're off each other. They're not exactly the same, so there's some distance away. So what we're going to do in order to basically formulate or like be precise on how different they are, their distance between, we're going to break it into the distance of y and the distance of x. So change in y right here is the y distance. Okay, change in x is right here is the x distance. So that's what we're talking about when we're talking about slope. We're just talking about the ratio of the change in y over the change in x. Now, this is a little confusing, not all that helpful. So another common formula for slope is that you have what we call y2 minus y1 over x2 minus x1. Now, what does that mean? Well, what we're talking about is we're talking about two different points. The point on the first one is going to be x, and then we do this little subscript 1 to differentiate it. x1, y1. Okay, this one right here is x2, y2. So the change in y over the change in x actually specifies the change from y2 to y1. So the distance of y2 and y1 over x2, x1, the distance of x2 over x1. And that's in relation to basically the coordinate plane. Now, here's the thing. How do we know which one is x1, y1, x2, y2? We don't. We just pick. The lovely thing about slope is that because we're talking about ratio, if it happens to be picking like this one as x2, y2, this one is x1, y1, the ratio is going to be the same. If you do it backwards, right, you say this one is going to be x2, y2, this one is going to be x1, y1. After you do the subtraction, they're both going to either be negative or positive. Basically, it ends up canceling each other out. It's still going to be the same ratio. So let's just look at that through specific examples. So I'm going to list several points, and we're just going to solve a bunch of different slopes in relation to these points. Let's just do, the first one's going to be 2, negative 1. That's one of the points. The second one's going to be negative 4, let's just say 3. And the third one, let's just say, is going to be 0, 2, just to make our lives easier. So what I'm going to do is I'm going to do, let's just say this is 1, this is 2, and this is 3. And let's just see how this slope formula works. So if I wanted to find a slope between point 2 and point 1, I'm just going to say this is x2, x1, y2, y1. And let's just put this right here. X2, y2, x1, y1, just for now. And so what we would do if we want to find a slope is we would use this formula. Our y2 is going to be 3. Our y1 is negative 1, minus minus is plus. x2 is negative 4. x1 is 2, so it's going to be minus 2. In the end, it's going to be 4 over, and then minus minus is going to be negative 6, which in the end is going to be, if you simplify it, negative 2 over 3. Okay, now I'm going to flip it over. So you guys can see that it ends up being exactly the same. Let's just say, for example, now I'm going to say this is x2, y2. This is going to be x1, y1. Okay, cool. Now, in this case, our y2 is going to be what? Negative 1. Negative 1 right here. And our y1 is going to be, well, y1 is going to be 3. It's going to be subtract 3. Okay, that's the top. x2 is going to be 2. x1 is going to be negative 4. So it's going to be minus, minus, going to be plus 4. So we end up with what? Negative 4 on top, 6 at the bottom. If we simplify, it's still negative 2 over 3. So notice that the order itself, it doesn't matter. If you're going to pick this one as x1, y1, and this one's x2, y2, as long as you use the formula and plug it in the same way, you're still going to get the same answer. If you flip it over, plug it in the same way, you're still going to get the answer. So that's how you would find the slope. Let's practice a little more. I can find the slope between these 2 points right here. So let's just erase this. Alright, so if I'm going to find the slope between these 2 points, let's just do x1, y1, x2, y2. Once again, I can flip it over, same thing. So, y2 minus y1, so it's going to be 2 minus 3. Here we are, 2 minus 3. And then x2 minus x1 is going to be 0 minus minus is plus. It's going to be 0 plus 4. So what is that? Negative 1 over 4. Okay? Well, I can do it with 1 and 3. Let's do okay, x1 right here, y1, this is going to be x2, y2. 2 minus minus 1 is going to be 2 plus 1. 0 minus 2 is going to be, well, 0 minus 2. That's going to be 3 over negative 2, or just negative 3 over 2. Okay, so that's how you would find a slope. Now, the important thing about this in relation to line is that if the 3 points or any amount of points belong on a line, no matter what order you choose, the slope is going to be the same. So I'm going to erase this. I'm going to give you guys 3 points that are actually on a line, and I'm going to demonstrate that they are exactly the same. The slope is going to be exactly the same. So let's begin. So here's 3 points. Now these 3 points are specifically designed to be on a line. So if you were to graph this, basically the equation is y equals x. If you were to graph this, it will look something along the lines of this. And the points right here is going to be negative 1, 1 is going to be right here. 3, 1, 2, 3, 1, 2, 3 is going to be right here. And I could go so far as to 7. There's going to be 4, 5, 6, 7, 4, 5, 6, 7. And it'll be like right here. So all these points are going to be on a line. Now, how do we know? No matter what order we choose, if we were to find the slope between any of these 2 points, the slope should be the same. So I'm going to start off with these 2. Okay, so I'm going to start off with, let's just rename them as 1, 2, 3 points. And then we're going to start off with this one as x1, y1, x2, y2. Okay, 3 minus a minus 1 is going to be plus 1 over 3 minus a minus 1 plus 1. As you guys can see, it's 4 over 4, which is going to be 1. Okay, great. Well, if I do these 2, let's just erase this right here, just so you guys can know what I'm doing. Let's do these 2 right here. This is going to be x1, y1, x2, y2. 7 minus 3 over 7 minus 3, which still happens to be 4 over 4, which equals 1. See, notice that their slope is still the same. I could even go so far as to work out this one right here, the 1 and number 3. If I were to keep this as x2, y2, and then instead I would make this one x1, y1, and I'm just going to keep this so you guys can see it, and let's just squeeze it right here so you guys can see that 7 minus a minus 1 is going to be plus 1 over 7 minus a minus 1 is plus 1, which is 8 over 8, which is still simplified to 1. So slope is 1, 1, and 1. This is an example of where all 3 points are on a line and the slope in this case is just 1. Alright, now you know the saying of, like, what do you call it? Beating a dead horse? This is the last thing I'm going to go over about slope to make sure I nail it in so that you guys can understand slope. Now this is different. I'm giving you each and every one of them a slope. I tell you exactly a slope. Now here's what we're going to do. For each slope, we're just going to come up with 2 points so that we know the slope of those 2 points is exactly the slope that's given. So let's look at this one. The first one, we have m equals 1 over 2. Remember our slope formula. Change in y over change in x, or y2 minus y1, over x2 minus x1. So all we have to do is, in this case, we can pick any point we want such that on the top, the y2 minus y1 must equal to 1, and the bottom, x2 minus x1 must equal to 2. So I can go nuts, right? In this case, well, any number, let's just say, for example, I'm going to make 2 points, and then we want the y2 minus y1 to be 1, so we can just say, let's just say 4 and 3. Why not, right? Because 4 minus 3 is going to be 1, and then x2 minus x1 equals 2. We can go nuts and say, well, let's just say, I don't know, 6 and 4. There it is, right? We can make up points, and we can continue. We can make whatever the heck point we want, right? From here, we can do the same thing. Let's just say 3 minus something equals 1. Well, let's just say that's going to be 2. Okay, 3 minus 2 equals 1, and then 4 minus something equals 2. Let's just say that's going to be 2. Okay, does that work? Yes, right? Because 3 minus 2 equals 1. 4 minus 2 equals 2. Well, does this work though? This and this? Yes. 4 minus 2 is 2. 6 minus 2 is 4. So it's 2 over 4. 2 over 4 in this case simplifies to 1/2. So you can go nuts and make all these kind of problems. Same with this one. 2 over 5. 2 points that will give you 2, the slope 2 over 5. So all you have to do is just pick the y2 and y1 such that when you add them, or subtract them together, you get 2. And x2 minus x1 such that you subtract them together, we get 5. So let's just make up some really quickly. Well, crazy number. Let's just do a 100, right? That works. And that means we would have to subtract 98 to make sure that we end up with 2. And then if we wanted to, we can do 95 and then 90. And those 2 points would still work as well, right? Free range. This one we sort of went over. I want you guys to give it a shot. Notice the pattern for at least the slope 1. It's actually pretty interesting. So thank you so much for watching this video on understanding and finding basic slope. Now for the last problem where we have slope 1 basically, hopefully you guys realize that the pattern with slope 1 is the interesting one, where no matter what number you choose, right, as long as you keep the y and x the same, then it's going to be fine. So let's just say example 5, 5, and 3,000. 3,000, right? They're always going to be the same, because guess what? Once you subtract it, top and bottom, they're always the same number. They cancel each other out. That becomes 1. That gives you the slope 1. All right? See you in the next video.